Okay, we're up to problem number 5. Okay, so we have this baby bird and it's gaining weight. And when the baby is first born at t equals 0, it weighs 20. Okay. Okay, and we're given a bunch of other stuff too, and let's just do one thing at a time. So let's start with part A. Is the bird gaining weight faster when it weighs 40 or when it weighs 70? So what you need to do is figure out the rate at which it's gaining weight. So the rate at which it's gaining weight would be the derivative of the function, which they give you. So this is the rate at which it gains weight. Okay, so how fast is the bird gaining weight when it weighs 40? So let's put 40 in there. And we get 12. So the rate at which the bird's weight is changing when it weighs 40 grams is 12. Okay, now we have to do it also when it weighs 70. So I'm going to put 70 in there. And we get 6. So obviously 12 is bigger than 6. So the question is saying, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So your answer is going to be the bird is gaining weight faster when it weighs 40 grams because the rate of change is greater at t equals 40. So that's part A. Let's go to part B. Oh, and this was worth 2 points, by the way. I think I forgot to give you point values on the other, so I'm sorry about that. But you may have those answers already anyhow, so maybe I don't even have to tell you that. But that was worth 2 points. All right, let's go to part B. Okay, so part B says find the second derivative. Okay, so this is the first derivative. I'm just going to write it a little bit differently. Now, if I want to find the second derivative this way, this is going to require a quotient rule, and I'm not big on the quotient rule. So what if instead I write it like this? And then that can be simplified to this. Okay, so that'll be a lot easier to work with. So this is the derivative, and we need to find the second derivative. Okay, so the derivative of 20 is just 0, and the derivative of negative 1/5 b is going to be negative 1/5 dB over dt. But the thing is that you know what dB over dt is. It's actually this thing. So I get negative 1/5, and then I replace dB over dt with 100 minus b over 5. And you can leave your answer like that, or you can simplify, whatever you want. Okay, so that's b. Okay, so that answers the first part of the question. Find the second derivative. And then it says, use that second derivative to explain why the graph can't look like the graph that they gave you. Okay, so you might want to simplify this to answer the second part of the question. So if we simplify, let me make some room. We get, multiply straight across, so we get negative 100 plus b over 25. And if we break this into 2, we get negative 100 over 25 plus b over 25. So all that is equal to -4 plus 1/25 b. Okay, that's the second derivative. And, okay, so this is what they're asking. All right, so why can't the graph look like it does, and what does it have to do with this? Okay, so this thing over here is the second derivative. This is going to have something to do with concavity. So what is the point of inflection for this? If I set it equal to 0, right, what else could I really do at this point? I get 1/25b equals 4. And then if I multiply both sides by 25, I get b equals 100. So that means that there is a point of inflection at 100. And it also means that the second derivative is always going to be positive. So if the second derivative is positive, that means the function is always concave up. But if you look at the picture, it's concave up and then it goes concave down. So this is what you'd have to write. The second derivative is always positive. So the function should be concave up, but part of the graph shown is concave down. Okay, so that finishes part B. And now we'll go to part C, which is kind of crazy and long. You need a lot of patience to do this one. So it's saying use separation of variables and use the initial condition to solve for the original. Okay, so we're starting with this. Now, there's probably lots of different ways to do this, and I did it different ways, and it got messier and messier, and I said there has to be a better way. So I played around with it until what I think was like the easiest way, but you might have done it a different way and still gotten the right answer. Okay, separation of variables means to cross multiply. So I'm going to get this. Okay, so you can't mix b's with t's, so we're going to divide both sides by 100 minus b. Okay, another thing that we're going to do is we're going to divide both sides by 5. The first time I did this, I left it as 5 over 100 minus b, and it turned into a huge mess. So I'm going to divide the left side by 5, I'm going to divide the right side by 100 minus b. Okay, and you get that. And then you have to take the integral of each side. Okay, so this is going to become ln of 100 minus b. But if you do a check to make sure you did it right, if you take the derivative of ln of 100 minus b, you're going to get 1 over 100 minus b times -1. So you have an extra -1, so you got to add a negative there to get rid of it. And the other side is just going to be 1/5 t dt. Oh, what am I talking about? Plus c. Plus c. Okay. You really don't want to deal with a negative ln. So if you just multiply every term by negative, you're going to get this. Now, I don't have to change c to a negative c because c just represents some constant. So whether it's positive or negative, it's just whatever that new constant is. Okay, I'm going to go to the next page. I'll rewrite that last line. Okay, we're going to use the initial condition now. And the initial condition is that when t equals 0, b equals 20. So when t equals 0, b equals 20. So we get ln of 80 equals c, because when we multiply by 0, we get nothing. So now I'm going to go back to this, and I'm going to replace that c. with ln of 80. Okay? So how are we going to get rid of all this stuff? We're going to add a base of e to each side. So for the left side, what that will do is, since you have a base of e and a base of e, the whole thing will just equal 100 minus b. And the right side is going to stay the same. Okay, so I'm just going to copy that onto the next page. Just want to make sure I copied the right thing here. All right. So a way that we can simplify this is to use an algebraic rule. Because remember, if you're multiplying same bases, you keep the base and you add the exponents. Okay, so if I did that, that would just bring me right back to here. Okay, what that does for me is it allows me to use the rule that I have a base of e and a base of e, so that whole piece just becomes 80. Okay, and now I'm going to bring the b, negative b to the other side, and I'm going to bring that whole e term to the other side. So I'm going to get 100 minus 80e to the negative 1/5 t equals b. Okay, and that was really long and kind of cuckoo. And that completes problem number 5.